All right, welcome to Lab 1, the first in our sequence called Our Place in Space, making use of the Skynet Robotic Telescope Network. Most of the labs in the sequence will make use of the Skynet telescopes, though a few of the labs will be traditional in nature, where you acquire measurements with your own hands. Now, Lab 1 is broken into two parts, which at most institutions will be carried out across 2 separate weeks. During this first week, you'll learn how to use Skynet, our image request system. And using Skynet, you'll observe a great many solar system objects, planets, moons, dwarf planets, and also a few deep sky objects, nebulae, globular clusters, galaxies. Skynet will then go off, collect these observations for you, get the data back to you, and then in Lab 2, you'll learn how to use Afterglow, which is our image analysis software that we also designed and developed ourselves. And you'll load your images into Afterglow and learn how to view them, how to adjust the brightness and contrast to bring details out in them. You'll learn how to make a few basic measurements, such as the sizes of objects, and how to identify which object is which in your images. So Lab 1, we're gonna have some fun. We're gonna image a whole bunch of stuff, and we're going to develop a basic skill set, a toolkit that you can then carry forth into the remaining labs in the sequence and build upon in those labs as well. Now, the remaining labs will follow what astronomers call the cosmic distance ladder. We'll start close in on Earth scales and work our way farther and farther out in the universe until by the end of the sequence, we're encompassing and studying the entire universe. Okay. Well, in this first overview, I'm just going to go through the instructions at the top of the lab. In the next overview video, I'll go through what's in the background sections, and then in the overview videos after that, I'll go through what's in the procedure sections, at least briefly. Embedded in the procedure sections are video tutorials that describe the tasks in even greater detail. Okay. So let's scroll on down and take a look at the instructions at the top of Lab 1. Now, these instructions are editable by your instructor, so they may vary a little bit from institution to institution, but they should be pretty similar to what we're looking at now. The first thing you'll see are these links to the overview videos, the first of which you are watching now, and I'm recording now. But as I just described, I will also overview the background sections and the procedure sections of each lab. Now up here, it says to read the background sections before beginning the lab. That's good advice. The background sections are full of useful and important information that you'll need to complete the lab and to understand what's going on. So definitely read them. And sometimes, not in this lab, but in some of the labs, there are points to be had in the background sections. So don't just skip over them. Okay, down here we have a note. And in most labs, this note is a reminder to put in your observations for the next lab. We like to put in the observations early so the images are ready when it comes time to do the lab. Now, this is Lab 1, and it's week 1 of Lab 1, and we will be putting in observations for week 2 of Lab 1. And that will be described down in the procedure section, a little bit lower down in the lab. Lab 2 is one of our traditional labs. It doesn't make use of Skynet, and so we don't need to put observations in for Lab 2. Instead, this note is specific to Lab 1. In Lab 1, you're going to be asked to try to observe as many planets and dwarf planets and moons as we possibly can. But you have to keep in mind they're scattered all around the sky, and many of them will be in the nighttime sky, but some of them will be too close to the sun to observe. And which ones are too close to the sun? It's always changing. From month to month to month, different objects are observable and different objects aren't. And I don't know in advance when you're going to do this lab. So I just give you the complete list of objects to observe, and you'll observe as many as you can. Some of them will simply be too close to the sun and you can't observe them, And you'll learn in the procedure how to know which objects are observable and which ones aren't. And sometimes only half the objects will be observable. Now what this means is you can't get all of the points in this lab. This lab is worth 130 some points, and most of those points are driven by the observations you will make. And if half the objects aren't observable, half the points aren't obtainable. Like you may complete this lab, observe everything you can, and only get 70, 80, 90 points. And that's fine. Now WebAssign is still going to display your score, but it's also going to display your percentage. And if you only get 70, 80, 90 out of 130, that's not the greatest percentage. And what I'm telling you is don't freak out by that percentage. You can ignore that percentage. All that matters is your score, and your instructor will figure out the best way to convert that score into a meaningful letter grade. Your instructor won't be using that percentage. Okay. Now the remaining instructions, the ones down here in bold, are the same in every lab. So I'm not going to explain them at the beginning of every lab in the overview video, but I will explain them this one time. And these are important, and you should heed these, because if you don't heed these instructions, you can lose a lot of points. So the first one is about saving and submitting. WebAssign lets you save as many times as you want. But if you forget to submit, your instructor won't get anything. You'll get a 0. Now, if you find yourself in that boat, you were using the save button and you forgot to press the submit button when you were done, you can go to your instructor after the fact, and there's a button they can press that will submit your saved answers. But it's cumbersome, and you don't want this to happen time and time again. Your instructor may get a little frustrated. So what I've done is I've set it up to allow you to submit up to 100 times for each individual question. That means you could change your mind 100 times on each part, each question. And you won't change your mind that many times. So my recommendation is just use the submit button over and over again, and don't even worry about the save button. Okay. The next point is to submit your work frequently. If you don't, you risk losing it. For example, if you're working on your assignment, on your lab, and then you go away for a couple hours and you come back, WebAssign times out, and they don't always tell you that they've timed out. So I've experienced this before. A student will pause for a long time, come back, complete the lab, press save, press submit, but nothing makes it through. So as you complete each part, you're going to want to submit it. And if you go away for a long period of time, you'll probably want to renew your screen and maybe log out of WebAssign, log back in. And then again, submit your work as you're completing it. Okay, the next point is similar to this. You need to have WebAssign open in only one place. Don't open it in multiple tabs, in multiple browsers. That confuses WebAssign, and you may do the work and submit it and nothing goes through. So only have one copy of WebAssign open. Now the remaining items have to do with submitting individual responses. And some of these responses will be short answers with words, but a lot of the responses you'll be submitting will be numerical in nature. So the first of these has to do with significant digits. The default is 3. You'll want to use 3 significant digits unless otherwise specified. Sometimes we'll say you only need 1 or 2. Now significant digits are different than decimal places. For example, 2.57 is 3 significant digits. Even though it's only 2 decimal places, it was 3 digits of significance. So submit 3 significant digits unless otherwise specified. And this is because the numerical responses, most of them will be auto-graded by WebAssign. And if you don't have enough significant digits, it can be marked wrong under certain circumstances. Okay. Now, sometimes the numbers will be quite large or quite small. You know, this is astronomy. We deal in very big and sometimes very small numbers, and you'll need to use scientific notation. So in WebAssign, you have to enter that in this format right here. For example, this is some number times 10 to the minus 3. The proper format is that number, then e, negative sign, 3. Don't try typing it in like this, like we say it, times 10 to the minus 3. Type it in like this, like you would in a calculator, for example. And then WebAssign will be able to interpret it. If you enter it this way, WebAssign won't know what you mean, and it won't even register as a response. The next point is don't add units, just enter the numerical answer. The units are usually written outside the box anyway. If you put letters in there with the numbers, WebAssign will get confused and it won't register. It'll be as if you never submitted anything. And finally, you'll be uploading some files. In this lab, there'll be images that you take. In future labs, there'll be images and also graphs that you make. When you save these files onto your computer before you upload them into WebAssign, just use regular characters. Don't use the special characters. Just keep it to letters and numbers. If you use special characters, WebAssign can sometimes get confused and lose your file. Okay, that is it for this video. See you in the next one.